simple diffusion, except you've got a protein in the membrane that helps. What could help? There's two ways of getting something from the outside of the cell to the inside of the cell. It's got to cross this barrier that things don't like to go through. And I think a good analogy here is human transport across a river. Let's say you're standing on the west side of the Mississippi River and you want to go to the east side because you're heading to New York. Well, first of all, I guess you could swim. It could be a mile wide, but if you're a good enough swimmer, you could just swim. And that might be like simple diffusion. So if you've got a huge crowd of people on one side and very few on the other side, some of them might decide to swim, and eventually you get some equalization. That's simple diffusion. It's dictated by how difficult it is. It may happen slowly or not, but that would be simple diffusion. If you were trying to facilitate that, how could you facilitate it?
A boat.
A boat. What's another way? A bridge. Yes, exactly. That's what we've got here. A carrier protein is like a boat or a raft. A transport protein or a pore is like a bridge. So a transport protein provides a safe passageway from one side to the other where it doesn't have to interact with hydrophobic groups. A carrier molecule is like a little ferry that picks up passengers on one side and it kind of encloses them safely in a little wrapping, and it diffuses across here and opens up and lets passengers off the other side. Both kinds of transporters exist. So here, for example, are some of this type, the transporter bridge-like molecules. These are permanent structures that just kind of sit there in the membrane, and they help facilitate the diffusion of molecules from one side to the other. This one, the step A, I only know a couple of these. This one is involved in iron transport. So iron molecules can get through here, through the pore. And you can see that these pore molecules are very complicated. They've got strands, segments that span the membrane and come back and go back and forth many, many times. So you need that to get the pore structure sufficient to identify the iron and to let the iron move through. This one is, you can guess from the name that this one's involved in transporting the disaccharide maltose from one side to the other. It's not spending any energy to do that. It just looks for maltose, and if it sees a maltose, it will help it cross. And so if there's a ton of maltose on the outside of the cell and you're a bacterial cell, this is good. This will let your food come in to the inside. So it's got like a pore down the center. Oh, here you can actually see this hemolysin toxin on the, in cross-sectional view. You can see that it's got a hollow center. So all of these would have hollow centers like that. And then they've got these loops at the top. These protein loops are involved in the molecular recognition part. So this one would look for maltose and not let other things in. But up here it recognizes maltose, it opens the door for it, and it goes in.
What was it that you said